Steve, watch that and let me know.
Keep up the good work, man, and stay flat, okay?
Okay, I'm a flat earther.
I think I'm getting the hang of this finally.
I think you are.
That's excellent.
Had
all
a
right.
practice today.
Yeah, well.
Oh my God, my cup. Look at my cup. It matches the stars. This is freaking awesome.
He gets so excited so easily. Well, for
Dude,
the fourth time
awesome.
tonight, you're at least seeing me again. So hello again for the fourth time. It's nice to see you all on this Saturday night. I think we're going to have a really cool discussion now. I think everybody in the room knows everybody, right?
Intimately.
No, Ali and I have
In a way
met
that no one
briefly,
described.
and we've emailed.
Good deal. And actually,
Yeah.
Steve, here in a minute, I'm going to let you introduce everybody since you go back. I just wanted to say that on the 16th, Trevor Valley will be back with us. He will be debating a gentleman he used to work at InfoWars, and they're going to be debating each other. They have a really heated feud on Twitter. Trevor is saying that he's going to smash his face in and embarrass him on the show, so it should be good. But yeah, Steve, if you will, please do the introductions. I know it's late, so I'm not going to waste any more time. We'll just jump right into it.
Sure, let's get into it. So we got Flight to Flat Earth back. Flight to Flat Earth has been with us a few times. He's ex-Navy nuke as myself, but it's the British version. Basically the same physics, but only spelled differently because they use funny little things like you and weird stuff. But yeah, he's come back on. He's going to have a discussion with a friend that I've known for a very long time, actually. Ali B and I, we go way back. He's like one of the first flat earthers to start coming around my channel, and I think Fight the Flat Earth said it best. He's probably one of the more intelligent flat earthers out there, if that's something that we can wrap our heads around. I'm voting for him tonight. I'm actually thinking that Ali B might change his position. I'm hoping, he's been good. He's been good in my
Maybe
channel.
he'll change my position.
No pressure.
He might. You know what? That might happen too. But either way, I'm going to sit back and I'm going to enjoy this conversation. So, because you're dealing with somebody who's not, I know, is not a Poe, and somebody who's not your bottom of the barrel person out there. So, I like Ali. He's a good guy for a flat
Good deal.
earther.
All right. Well,
No, I appreciate it.
let's let them introduce themselves and tell us a little bit about how they got involved in the flat Earth discussion. And we'll start with the new guest first, Ali.
Oh, nice one, Kyle. Thanks. Well, I've been in this discussion maybe about 5 years. As Steve says, we go back a bit. I can't remember the first video. Could have been Eric DeBay or whatever. But I just kind of laughed, and I kind of started looking into it, and I found out that the evidence was lacking, or the evidence that was getting produced, or the, shall we say, the quality of information, didn't satisfy me. And here I'm still thinking the same as I thought then. So that's about it.
All right. And Fight the Flat Earth. Should we scream
Hey,
so you feel more home? Fight the Flat Earth.
No, please, it's really early in the morning here, and my daughter wake up. I've not been in the discussion that long. I literally only started looking into it about a year ago, and Ali was actually one of the first videos I came across. And then a couple of months ago, my wife told me to stop sitting around doing nothing and do a YouTube channel. So I did as she said. And I've really enjoyed doing it and looking into the physics of it. And I feel like I've actually relearned a lot of stuff myself. A lot of the flat earthers that I've met are just so unwilling to actually have a discussion or are complete pose. So I'm actually really happy to have a debate with someone like Ali, who I think I can actually have a proper conversation with. So yeah, how you doing, Ali? It's nice to meet you, mate.
Yeah, how you doing?
Sweet.
Tired, but we get there.
Well, where shall we begin?
I don't know.
Well, can I ask, what's your biggest reason for thinking that the Earth is flat?
Well, there's a few things, but as you know, we had a discussion the last time about an attitude indicator, and you flung in pendulous veins, and you know, you admitted that you didn't know enough about the subject. You'd go away, read up about it. So this was kind of, we could start there if you wanted to.
Yeah.
If you want to describe.
Yeah, I mean, I've gone and studied some maintenance manuals and stuff for a lot of aircraft instruments, and tried to look into the operations of them. I'd like to ask you how you think pendulous vanes work, and we could go from there. So, what do you think the pendulous vanes do?
Well, they correct any perturbation or any movement of the gyroscope off its fixed position, where it gets where it's set, where it's calibrated from. It'll hold that position, and if it starts to process or move out of that vertical or perpendicular to where it was calibrated, it will correct it through like inertia. It's like inertia because it has a bit of spring where it's attached, so it has a bit of inertia, and that actually corrects the gyroscope back to its upright position.
Well, first off, the springs haven't been used in pendulous vanes for many years. They work now off of a fluid that is moved about, based, like you said, as there's perturbations, a fluid will move about. And what the fluid does is there's 4 parts that allow air in and out of the pendulous vanes, and there's 2 sets of opposite vanes that are attached. As the gyro tilts left or right, it covers the fore or the aft parts, the ports, and then it causes it to close, and that creates a pressure that will force the gyro to right itself until there's an equilibrium in the pressure. And the thing is that what makes it actually do the correction in the first place is the force of gravity. That's what's making the actual vanes that are connected move. As the plane moves, it's gravity that is causing them to shift and causing that movement within the pendulous vanes for the ports to get covered. So the operation of, I mean, there is some models of pendulous vanes that instead of using a fluid that covers ports, they use like ball bearings that move around on a circular disc on each side. But in 90% of the ones that I read up about, it is the versions that are connected and have a fluid that covers ports to allow air in and out, which won't work without a downward force. And unless you can give me something else that is causing that downward force, then my conclusion is that it's gravity that allows the pendulous vanes to correct the perturbation of the actual mechanism.
Right. Well, the spin of the gyroscope creates that force, the centrifugal force. It overcomes gravity.
What, so you're saying gravity?
Gravity. Well, look, gravity is one of the weakest. The spin, you can actually prove it if you. Right, we can agree that. Do you hold true to that gravity gives a thing weight? It creates the weight because if you put on a scale, it's the pull of gravity that's pulling against the mass of
do you know what the mathematical formula is for weight?
I don't care about that. I'm just asking, is that how you see it? We don't need to go into maths. Just as, would you agree that...
Yeah, I mean, it's the pull. It's the correlation between the mass of the object and the gravitational force that gives it the actual amount of force going down.
Yeah, that's what I mean, the weight. We could say it gives it the weight.
Yeah.
But a gyroscope can overcome that. If you get, for example, a disc, and you put it on the end of a stick, on the end of a bit of metal that it's free to spin, and you get that up to certain revolutions per minute, you can lift that basically with one arm. Whereas if you try it when it's not spinning, it's still the same weight. The only thing that's changed is this thing's spinning. So gravity doesn't affect the pendulous vanes or any of that gyroscope spinning at all whatsoever. It overcomes, and they'll use.
Okay.
That's why they use it out in space to correct their attitude. They use gyroscopes inside that because it doesn't get affected by gravity.
If you're saying that a gyroscope can just correct itself like that, then pendulous vanes would be surplus to requirements because they are what.
No,
correct.
it doesn't. It doesn't. That's what I'm saying. When they're only to correct, they're to help the correction, because when it's inside the instrument panel, it's surrounded with electromagnetic forces. It's due to vibration and everything, so it will. All the forces acting on all the different acting upon it under acceleration as well. It'll react on that, and it has to correct itself under acceleration or fast movement. However, it corrects due to the pendulous vanes that adjust it back into its upright position, and it'll stay there forever and ever.
When you're saying about inertia, that is actually part of the operation of the pendulous. Sorry, carry on.
1 second. And the only way that gyroscope is going to come off of there is if when it slows down, and that's when your so-called gravity, when it starts slowing down, it starts going like that, and that's when your so-called gravity comes into operation. But before that happens, it's defying gravity, so gravity doesn't come into that. So you can't say gravity inside attitude indicator causes that, because it's not. It's just nonsense. It goes against physics.
Okay. I mean, I have to completely disagree that it goes against physics, because it all actually agrees with the maths and physics of the model. You're talking about inertia, and that's part of how they operate. When an aircraft turns, inertia causes the vanes to lag a little.
Inertia? Explain to me then what inertia is. Actually, what is it?
Sorry, I have to get the actual formula. I'm buzzed on coffee
right
now.
Not the formula,
so
just explain what it is. Is it a force? Is it
the formula is weight equals mass times g, by the way, if you're looking for that.
Yeah, I mean,
but
inertia, when you're in a car and you stick on the brakes, it is a force. It's classed as a fictitious force or a pseudo force. It's within the reference frame.
Inertia is the resistance to change of direction or vector due to applied external force.
That's it, exactly. So if you throw a ball, that's got inertia, and it's also got potential energy, but you can only measure that when it hits something, right? But it's got inertia, and that inertia is just exactly what Steve says. It's just a force introduced to an object.
Okay, yeah, but inertia isn't the entire operation of it, because the actual pendulous vanes themselves are suspended and held in place by gravity. And when the aircraft turns, an inertia of the vanes causes a little lag, which then creates a force moving back and forth and accelerating, as it would tilt as the aircraft goes forward or backwards, and do the same as I was explaining earlier with covering the ports on the pendulous vanes. The whole operation of it requires a downward force on the actual vanes, because they are suspended by and held down. And if there isn't a down, you're saying about there's electromagnetic forces or whatever in there, that's not going to
that's what they are.
change
That is a fact.
What's a fact? The electromagnetic force is going to change what
that cause perturbations in a gyroscope, and that's why they have it.
See, now all the operations manuals of all the pendulous vanes I was reading would disagree with you. So can you explain why this the information that I got was actually from operations manuals and manuals of when they were put together.
Yeah.
So why would the people that are putting it together be given all this information that isn't right?
Well, that is right, because if you've ever been in a plane, it shakes. So there's forces,
that's
there's
not
vibrations.
Really, that's not
acceleration.
That doesn't change the fact
listen.
that the pendulous vanes require a downward force.
No, it doesn't. It doesn't require. It's
according to the manuals, it does.
The force is caused by the disc that's spinning, or the centrifugal force of the gyroscope. That's what's keeping it upright.
Well, the pendulous
And
vanes are
when it
separate to the
moves due
gyroscope.
to
They're not
vibration,
connected
listen,
to it.
when it moves due to vibration or magnetic or whatever when it starts coming off its center like the Earth is meant to have, right? When it starts precessing or whatever, it's when the pendulous veins kick in, and that's when they do their job. It's got nothing to do with gravity, because gravity doesn't come
Again,
into the,
it does, because there has to be a downward force on the pendulous vanes.
The centrifugal force overcomes gravity.
You keep saying it overcomes gravity,
Now,
and then
you
telling me
can
gravity
disagree
doesn't
if you
exist.
want.
But let me talk for
No, I
a sec.
says
Right?
it overcomes.
The fact is that there needs to be a downward force on the pendulous vanes, a downward force, not electromagnetic force,
Why does
nothing else. The
gravity
pendulous
down?
vanes, which are separate to the actual gyroscope, need a downward force for them to be able to operate.
No, they're
They
actually
have to have it
attached to the gyroscope.
Guys,
They're
we
not
gotta-
Well, no,
separate.
they're
attached.
suspended above the ports
We gotta-
that are
we
within
gotta
the
start
No,
actual
they're not.
pendulous
one at a
vanes.
time.
Yes, and they're
'cause
attached.
everybody's talking over everybody, and nobody can hear anything. So we got to go one at a time. Make sure that there's a little bit of a lag with the system. Just if it feels like you're getting stepped on, I'm sure that's not intentional. Just let each other finish the thought, because coming out in the feed, you can't understand anything.
Okay,
It's a hot mess.
let me just reiterate that the information that I got from the operations manuals of the actual pendulous vanes, and I could provide you with the links for where I got this and all afterwards if you'd like. They actually within them say that there needs to be that there is a downward force on the vanes that are suspended above the ports, and they're held in place by gravity. The word gravity is actually used within the manuals of the the operation manuals of these things. So why would they be saying that? Why would they be saying that there needs to be a downward force, which they actually name as gravity, acting on the pendulous vanes, if it's not true? Remember, this is based on what the people need to be able to operate, maintain, and build these things.
Right, but as I'll reiterate, the pendulous vanes are attached to the gyroscope, and the spin of the gyroscope overcomes gravity. Because if not, then, right, if not, and I know what you're going to say to this, if not, and it's such a cheap shot, this, but the mass of the aeroplane surely would affect the gyroscope. It's gravity of that aeroplane. Surely that aeroplane has gravity.
Ali, I'm going to tell you, I don't think you know what a gyroscope is. A gyroscope is an instrument that maintains its rigidity in 3D space, no matter what's happening, unless there's another force acting upon it.
Yep.
Yeah, you're agreeing, but you're making my point for me.
Yep. But I'm talking about the forces that are electromagnetic. In an attitude indicator, we're talking specifically about an attitude indicator here. If you want to put it up in space,
I can talk to you about that, which links to the operation.
They use it to adjust, because it's not. They use it to adjust the ISS, the attitude of the ISS, and everything. They use
Actually, backwards there.
It's not affected. It's not affected by gravity, because they push against it. They push against the actual spin of the gyroscope. So it's actually that maintains its space, and it pushes against and adjusts the attitude of the ISS, and that's the strength of gyros, and that's not getting affected by gravity.
Well, everything's affected by gravity. But again, when you're talking about the attitude indicator, can I talk, please? Can you please stop interrupting me? Thank you. I'd really appreciate it. Thank you. Like, the attitude indicator is actually told what to do by all the pendulous vanes in the operation of the gyroscope. It's not the other way around. The attitude indicator, the artificial horizon, is told what to do based on the operation of these things. It's not the other way around. So, and then I have to go back to the point that there has to be a downward force on the actual pendulous vanes. We're not talking about the actual gyroscope, because the pendulous vanes are suspended above the ports, within the whole thing, and they are held in place by gravity. These words came directly from the operations manual of a company that builds these gyroscopes that go on planes. And again, I can give you the links for the information of where I got this. So they themselves say that there has to be a downward force on the vanes that are suspended above the ports, and that is gravity. And then the whole operation of it, when the aircraft's moving and the inertia and the lag, it creates the force, and then all that tells the attitude indicator and the artificial horizon what to do. It is all reliant upon gravity. And unless you can give me an alternative for what is causing that downward force on the vanes that are suspended above the ports, what is that downward force? There has to be something that is giving that a vector, a downward force. And the only thing that there is that would describe it accurately, along with the mass of the plane and everything else that is going on, is gravity. The law of gravity, which is a mathematical formula which can predict everything, can explain everything that's going on. I can give you the math and the physics that explain exactly what is happening now that I have studied the operation of the pendulous vanes. Gravity is the answer. I'm done.
Well, that's what we'll just have to disagree on, because I'm still maintaining that the spin of the gyroscope overcomes the gravity, and you can prove.
Can I ask why you think that, Ali? I know this is between you guys, but this is physics, so
yeah, okay.
Why do you think that? Why do you think it overcomes gravity? If I can ask.
Well, they used that system like in the lunar. They used gyroscopes in the lunar modules, right? And they use it to adjust the attitude if they were going to get affected by gravity. If you know it, they wouldn't know which way was down.
I don't understand.
They wouldn't know.
No,
right,
I'm quite confused as to what you're saying. I mean, they maintain their rigidity of 3D space.
They wouldn't know which way is down, right?
No. Right, what I'm asking you, right?
So listen. So they had the gyroscopes in space in a proper vacuum where it's floating or whatever, yeah, held a position and weren't affected by the gravity of the moon, and it flew over it. So therefore, the gyroscopes overcome gyroscopes. The force, the centrifugal force, negates gravity.
No,
and it's nothing.
I mean,
to do
you are
with
right that
pendulous
centrifugal force is stronger than gravity. I mean, many orders of
thank you very
times
much.
stronger.
well, actually, it's not the centrifugal
that doesn't
force.
mean
It's
that.
actually, well,
It's
Sorry,
centrifugal, I said.
That's not why a gyroscope works. I think either of you guys are a little off on it. When you have a gyroscope, okay, and you write it as rigid in three-dimensional space, but it's because you have a cross product of the radius with gravity, and so you have this conservation of angular momentum that's causing it to stay in a fixed plane, that's causing it to rotate in a precession-like a thing. So whenever you tilt it, it's always going to try to stay with the same amount of time rate of change with respect to the radius vector to the gravitational force. So it doesn't override gravity. It's what it is. It's just it has to maintain torque because it's having that precession, because it's rotating, and that's going to cause it to go in a path that's a time rate of change with like I said, the cross product or the dot product. I don't remember. It's one or the other. I haven't looked in a while either.
Right. Okay, that's fine.
It's not so much conservation of. Go ahead.
Oh, right. Yeah, but that's fine. That's the point. But if you set a gyro going, even if and taking friction out of the equation and being able to keep a gyroscope rotating for whatever 24 hours, and there's plenty proof of that, it won't precess.
Well, it will if you've got an accurate enough gyroscope. Bob from Globebusters.
No, because there'll be no force acting upon it. And I can bend it like that, I could put it like that, and as long as it's going fast enough, it will hold its position there.
Well,
if it slows down,
there's mechanical gyroscopes.
Dude, but when it
there is
slows
mechanical
down,
gyroscopes that can show the 15-degree shift per hour. You know, how do you explain the gyroscopes that do show
mechanical.
it?
No,
there is.
Mechanical.
If you get a big enough and accurate enough, there's actually a video on MIT's YouTube channel of them building a mechanical gyroscope specifically to show this. If you get one that is accurate enough and big enough, then it will show that 15-degree shift. They knew this before there was digital and everything on it. It's, you know, a lot of gyroscopes aren't accurate enough to actually show that. When you get one that is, but
okay,
you know,
I'll go look at that, but that would change. Sorry.
Yeah. Right. Okay. So I feel like we should move on. I mean, from gyroscopes. You know, I hope that you understand that I really wanted to go and look into the operation of it so we could have a good discussion. And I understand that what you're saying, but I have to disagree with your assumption that it's not gravity that is causing everything to work.
Well, your assumption's gravity in the first place, so.
Well, no, gravity
I
is
can
a
explain
mathematical
it,
law
look,
that can predict and explain
I
things.
can make it.
Well, he's got
I
a
can
point.
explain it.
Fight the flat Earth.
I can explain it without gravity, right? I can explain it without gravity.
You need
But
dropity.
you've got to bring in this mystical force.
How can you explain it
Something
without
you can't
gravity?
measure. You can't measure it. Well,
Weight times
it's
buoyancy plus height divided by density.
No, that's
Dropity.
its natural. That's its natural. That's matter's natural direction in this atmosphere. Is towards the ground till it hits something.
Okay, you're saying that, but when matter is moving towards the ground, not only is it moving towards the ground, but it's accelerating. And I'm pretty sure you understand acceleration requires a force. So where's that force coming from? We can do the calculations of why things are going down, but weight requires gravity as a function of it. There still has to be something that's given it a vector to go down. You can't just say it goes down because that's its natural state. There has to be something that is actually giving it a downward force.
Why does you explain to me why? Excuse me. Explain to me why then there has to be a force upon that to make it fall down.
Because acceleration requires a force. Because that's a proven scientific fact. Every time you can do the maths and physics and acceleration.
If you drop something from a height, that's creating force. Or well, it's not actually creating force. You can only measure that force when it's hit the ground.
There's still you're missing the point. There's acceleration.
No, I'm not missing the point at all. Yeah, a big deal. So what's acceleration? That thing's falling.
Acceleration requires a force is my point. That's a fact that no one can dispute. Acceleration requires a force.
Not unless it's falling. It doesn't need it to push something or to project something out the way.
Why is it going down instead of sideways?
You can drop things, right? You don't need it. You don't need to rockets aiming down to drop it. You can just drop it, but to propel something that way, any other
you're absolutely right.
You need a force, but not to you've made something up when you're presuming that you need a force for things to fall.
No, I'm not presuming anything. I'm making an observation that it's accelerating at 9.8 meters per second squared, and I know that acceleration requires a force.
Yes,
can you deny the fact that acceleration requires a force?
And that way. Yeah, but
why is it different?
Direction.
No, it doesn't.
It depends.
Why does it depend on the direction? What gives it that direction? There has to be something that
need a force.
Yes, it does.
You don't put a force into it. No, why?
Of course you do. You need a force for anything. If there's acceleration, there has to be a force.
Y'all got to listen. It's a hot mess. Y'all have to let each other finish because
this is painful.
You're going over top of each other. You have to let each other finish.
Yeah, you guys are walking at each other, and you guys are talking so past each other that I'm just trying to take it all in and get the physics, and it's like you guys are speaking different languages. Trust me.
Take a breather.
And so take a breath. Fight the flat Earth. Why don't you explain to him, like if you drop something off a cliff or something, why you have a negative acceleration of 9.8 meters per second squared towards
I'm
the
gonna
ground?
go simpler than that. I'm gonna say, right, I've got this book, okay, and I'm gonna let it go. So what you're saying, it's just gonna go down because, right? But because of what? Right? Why does it not require? I haven't finished. Why does it require a force? Why does it not require a force to go that way, but it would require a force to go that way, or that way, or that way? Why not that way? What's changing? And again, I remind you, it's not just going that way; it's accelerating at a measurable speed. So I just need to know why it doesn't require a force to go that way.
Do you want an answer now? Right. Yep,
yeah,
because
please.
It's heavier than the medium it's in. Simple as.
Well, actually, okay, I'll go back to the book, right? Right?
Yeah,
you're saying it's heavier than the medium here, right? So the air here is less dense, yeah?
No, I say you're not going to even suggest it. Why doesn't it float up? Because it's heavier than the medium.
That point. But it's
no,
also heavier
because
than the medium above it.
It doesn't matter. It's heavier than the medium below it, so it's going to fall due to weight. So what's the problem?
But it's also heavier than. Right, you're saying it's heavier than
matter.
the medium
it's not
below
inclined.
it.
It needs.
You guys have got to stop talking over
really
each
don't
other.
want to. I really don't want
All
to use
right,
the mute
let
button.
me finish.
I'm gonna have to.
It's so bad. It's a hot mess.
All right, okay. Let me answer you. So that I get it right, what you're saying. That it's because that book has to accelerate downwards, and you're asking me why it doesn't go up the way. And I'm saying why it doesn't go up the way is because it's heavier than the medium below it as well as above it.
No, he's asking you what's causing the acceleration, Ali. He's asking you specifically what's causing the acceleration in the direction of droppity down. That's what he's asking.
It's weight. It's weight.
Weight's not a force.
It doesn't
There has
need
to
a
be a
force.
force for acceleration.
It only needs a force to go up the way. Why should it have a force to go down the way? It is heavier than the medium that it's in. In the story, what's complicated about that? Why do you have to bring in a mystical force?
No, I'm not bringing in a mystical force. I'm making
man.
an observation that acceleration is happening. And it is a fact that acceleration requires a force, no matter the direction it's going. You're just saying it doesn't require a force going down because... But that makes absolutely no sense. Why? But it's also... you're heavier. You say... Then why doesn't it go up? Because it's also heavier than the medium above it. And in fact, the medium above it is even less dense. No, but it's also heavier than the medium above it. And in fact, the medium above it is even less dense than the medium below it. So you're literally telling me, by your logic, that it should be going up.
No, I'm not. You're trying to make it sound as if that's my logic. I'm telling you it's the weight because it's heavier than the medium that it's in, whether it be below it or above it. It is naturally inclined because it's weight in this atmosphere that it goes down and it stops when it hits something. End of story. It's not complicated.
Why?
You don't need to add a mystical
You do. You
fairy story into it.
Why?
By the way,
But
can I jump in real quick? There's a technical thing people in the live chat pointed out. And here, to me, weight isn't a force only for the fact that even though it's measured in newtons, but it's actually the object's. It's the force of gravity acting upon that object's mass, right? So it's the force of gravity that's acting upon that mass. That's what we're calling weight. So some people can say, well, weight's a force. It's measured in force. But I personally think it's the force of gravity operating on the mass itself. So maybe it's a technical point, but because weight is the force of gravity, right? Weight is, to me, isn't.
No,
the
that's
force.
that's a good point. I like that. I like that, Steve. That's a good point.
Take it for what it's worth. I mean, but that's how I remember it. Is weight is the force of gravity acting upon the mass. So you can call that, in a nutshell, a force, but it's actually not. It's the force of gravity on that object.
Within Newtonian
right, and
physics,
I would say
basically a force.
Yeah.
And I would say it's not gravity that's acting upon it. It's not a force. There's not any force. It's just falling as it is. But it's still
not
a
just
force,
falling.
where you agree.
Right, because if you have
force.
that mass in a zero G environment, there's you have no more force acting upon it. So it's contingent upon that gravitational force being on it to have that weight. So weight itself doesn't exist unless you have a gravitational force with it, right? Weight equals mass
No, it
times
still
G.
has. It still does, but you can't weigh it. It still has that mass, but you can't weigh it though. If it's floating in space, there's no real weight unless you've got some way of measuring it if it bumps against you, but you can't actually physically weigh something that's floating. Really. So you can't, it still weighs that, if you took it down here in this atmosphere, it would weigh something, not because of gravity, it's because you can weigh things in this atmosphere. But we can't do it up there because things float up there, they don't fall anywhere. So I don't go with the gravity. I don't need the gravity, you don't need gravity to explain things.
Well,
but anyway.
We do. We all need gravity because the calculations are reliant upon gravity to be a thing. The buoyant force formula requires gravity to be a thing, and not only is it a thing, but it's able to calculate and predict what can happen. And you're still just saying that it goes down because that's its natural inclination. That makes no sense. Every other direction requires a force. We can't just say that one doesn't because that's its natural inclination. And like I said, it has acceleration. You have to explain why it accelerates. There has to be something acting upon it to make it accelerate. It's as simple as that. And you can't give an explanation for that downward force.
But it would, if I just dropped that, say the atmosphere was like infinity, right? And I went up to the top of that, as far up as I go to drop that object, and it was infinity, yeah, it would keep accelerating, wouldn't it? Until
it would reach terminal velocity because of the buoyant force of air underneath it.
There's no friction, right? But
you just said the atmosphere would keep going up.
Yeah, but
you said if the atmosphere is all the way up, and atmosphere is what gives it friction.
Right, okay, so eventually it would just float then before it hit the ground.
If you're saying it would reach terminal velocity, which is an equilibrium between the force of gravity and the buoyant force of air underneath it, and maintain that velocity until it reached the ground.
Right, so if it was, as I say, if it was infinite miles away, what would be the terminal velocity? You said 9.88 meters per second.
That's the acceleration of things within Earth's gravity, yes.
Right, so it exponentially accelerates. When does it stop? When it reaches the terminal velocity?
Yes.
So would you say that all objects have the same terminal velocity?
Well, the terminal velocity will be dependent on like the mass of the object and the force down and the force up. Is an equilibrium, but most things will probably, if a bunch of people are jumping out of a plane doing skydiving together, all those people will end up going at the same speed because they're all traveling at terminal velocity and accelerating downward at the same speed. So terminal velocity is dependent on the forces acting on it going down and then the forces acting on it going up because of the buoyant force of air. It's an equilibrium. Nothing's going to go past that terminal velocity.
So are they all equal then?
Well, the gravitational force is equal in everything. It's the mass of the object is the variable.
So it's not as there's like a terminal velocity for all different objects, or different masses, shall we say? If we had different masses, for example, if we had the size, for example. Right, and you had two objects the same size, but one was denser than the other. Would they reach the same terminal velocity? Anyway, this is going off the subject. Forget that.
Terminal velocity has to do with the fact that you have wind resistance as it's like dropping down, right? So if you have a greater surface area, it's going to have a higher degree of drag and resistance. That's what causes terminal velocity.
Right, so in a vacuum up in space, if I threw something, it would continue to accelerate.
Yeah, object
no.
in it. Well, no, it wouldn't.
Well, you've just said that the reason it reaches terminal velocity is because of atmosphere, right? So if you're in a vacuum and you throw it, it would continue exponentially accelerating. If I throw it at 4 meters per second.
No, because as you increase in acceleration, you then require more force to keep accelerating. Because your acceleration.
But wait a minute. What's stopping that? What's stopping that? If there's no atmosphere there, there's nothing to stop that. There's nothing to
It wouldn't keep accelerating, but it would travel at a constant velocity because objects in motion will stay in motion unless there's a force stopping them.
Right.
It wouldn't keep accelerating unless there was a constant force on it.
Once you impart some energy to that system, Ali, right? Once I throw something in space, right, it's going to go on a certain vector course, right? But there's no more energy going into that system. I'm not adding any thrust to it. I'm not adding any energy to it. It's not going to accelerate. It's going to stay at a constant velocity because there's nothing to impede it, nothing to slow it down. So it'll just keep going. I mean, you have minor things like you have 1 proton every cubic centimeter, but that's going to be nominal. But it's pretty much going to stay at the exact same speed in the direction it's going, regardless of anything else, unless it's acted upon by another force, right? So if it moves towards Jupiter, right, now Jupiter becomes a predominant force, and its vector is going to change, because as Flight to Flat Earth said, things that tend to stay in motion will change be in the same vector unless acted upon by outside exerted force. So it's not going to accelerate. It's not going to keep going faster and faster and faster, because there's no more energy going in that system once it's left your hand. Does it make sense?
But the reason you just explained,
it's really not.
Yeah, but the reason, but the reason you just explained that a thing reaches a terminal velocity because it's got drag with the atmosphere, yeah. But in space, you don't have it. So when you throw it, it must continue to accelerate. Take away all planets, right? Forget about planets.
If you didn't, wait.
Yeah. So you're taking away the planets, then you're taking away the force of gravity, which is causing the acceleration downwards. If you're just throwing something in space with nothing around, then once that initial energy has been dispersed in the acceleration when you throw in the thing, then it's just going to stay at that constant velocity unless there's another force acting upon it. If you're near a gravitational force like Earth, then the acceleration is going to kick in because there's a force pulling it down.
All right, what happens if I throw it at the same? Right, what happens if I throw it at the same speed as gravity then?
Speed as gravity.
Well, gravity. You need to have an object around for gravity. Well, yeah, but that's what happens if I on Earth.
Right, that would keep accelerating because it would never reach a terminal velocity because there's nothing up there. If I threw it at the speed of gravity,
accelerating.
Yeah, but it would be because I'd be throwing it at the same speed as gravity, which is 9.8 meters per second squared, or whatever you want to call it.
Well, yeah, right? But there's not a constant force on it. Gravity is a constant force that is pulling it down. Once you have thrown once you've thrown it, right? Once you've thrown it, if you say you've thrown it at 9.8 meters per second squared, for that initial way you're throwing it, that is going to go at 9.8 meters per second squared. But then there's no more energy, and it's just going to go at a constant velocity. When you're on a planet, when you're in Earth's atmosphere, in Earth's gravitational field, the reason it's accelerating is because there is a constant force on it. When you're throwing it, that's the force. It's done in space, right? And then there's no more force to give it acceleration after that. But if it's falling on Earth, there's a constant force because of Earth's gravitational field, which is the reason it would keep accelerating. If in space, that thing that you threw, you had a little rocket on it, it would then keep accelerating until the fuel was exhausted. And that's the thing. It would keep accelerating until the force was gone. Once there isn't a force anymore, it's not going to accelerate. It's going to stay at a constant velocity, which isn't acceleration. It's just a constant speed. It's not going to speed up anymore. Yeah, I can't make it any simpler than that.
Yeah, I mean, that's pretty well spot on, man. I mean, think about this way, Ali. And by the way, I know this is between you guys, but this is just making my head freaking hurt.
No, that's all right.
And you're doing a great job fighting for the Flat Earth. But Ali, because I know you, maybe I'm trying to speak in a language you maybe understand better. But look, if I have a position here and I go to this position here, that's called a displacement, right? You grant that? So position 1, position 2, displacement there.
Yep.
Okay, so the change of displacement is my velocity, how fast I'm moving from one place to another. Would you agree? That's called the first derivative of position, right?
Right, go on.
You want a derivative is? Because I've talked about this before.
Yeah. A derivative is something that comes from it comes from something else. So
it's a time rate. It's a time rate of change. Okay, so let me explain it to you. So if I have a change of position, right, the displacement is called. The time rate of change of that, the first derivative, would be called velocity. But if my velocity is changing, which is a change of direction or magnitude, right, either one, then that change of velocity, that's called acceleration, which is the second derivative with respect to the position. So what I would recommend is maybe you need to look into the kinematics here of what these terms mean, because all I hear is it's like the Flat Earth's trying to explain these things. You're not understanding the terminology, and it's just leading to a quagmire of complete fuckery, to be honest with you. Because these are basic kinematic understandings of what these terminologies mean in physics. So when he's saying things like acceleration, you have to understand what he means by acceleration. It literally is the time rate of change of velocity, or the second derivative with respect to position.
It's a change of speed, basically.
Well, it's a change of velocity. Speed is a scalar. Velocity is a vector, right? So it could be a change of magnitude
Yeah.
or direction. But this is why you're not conceptualizing it properly, that if I throw something, there's no more change of velocity there. The velocity is imparted, it's moving, it's going in a direction, and it's going in a magnitude, but there's no more energy going in that system. It's no longer change acceleration. But if you went near a planet, what happens, fight to flat Earth, when you have a gravitational field now?
Well, this is how they got Voyager out of our solar system by slingshotting around Jupiter, wasn't it? So it has that initial energy whilst it's leaving Earth, and then it's traveling at a constant velocity as it goes towards Jupiter. And then as it got towards Jupiter's gravitational field, which is a lot bigger than Earth's gravitational field, it made the satellite speed up. And I think they did 3 orbits before they then changed the vectors of it using thrusts to then use that energy it gained in the acceleration to fire out of the solar system. And the reason it sped up was because it got towards the gravitational field of Jupiter, which gave it another force. But until it got to that, it was traveling at a constant velocity. It wasn't increasing in speed, it was just going the same speed.
Does that make sense?
Right.
No?
Yeah, absolutely, but it still doesn't answer the fact is if I introduce that force at the inertia into an object in a vacuum and accelerate it at 9.88 meters per second or whatever, it will continue at that rate because there's nothing acting upon that.
You realize that that's only the gravitational force of the Earth, right? Gravity is a
and that's what, and that's exactly right. And that's what you see brings things, and you say that's a force or whatever. So I'm introducing the same force.
Yeah, but then you're not giving it a constant force. You're just giving it that force at the beginning, and then no more.
Yeah, but that's all.
The thing is,
that's all it would. Right, listen, because that's all it would need, because there would be no gravitational pull. There'd be nothing fighting against that. So if I put that energy the energy needed to make that accelerate at 9.88 seconds per second or whatever, meters per second or whatever it is. If I put that in there, there's
I think this is where the disconnects come in, because like what you don't understand is that once that initial I am, and I'm trying to explain that you've got a disconnect between what acceleration and velocity is, because once you've given it that initial energy, it's not then going to continue having that energy. To continue accelerating, it needs a continual force, and you're not giving it a continual force. You can't compare one to the other.
I don't think you're getting it. So hang on, Ali, hang on. I don't think you're getting it because you don't have the prerequisite knowledge to understand the topic properly. And
no, I don't agree with it, Steve.
Well, but here's the thing: you can't agree. You can't agree or disagree.
I don't agree with it, and I don't care.
Ali, let me finish, please. You cannot agree or disagree without being properly informed. If you don't know the basics, you're not going to be properly informed to make an educated decision one way or another of what he's telling you or I'm telling you is correct or not. And the light feed is just, they're basically saying, what's the point of this? And I agree. You're not really understanding a word of what is being explained to you, that if somebody went to go into a first year college physics course, they would be all over this, right? They'd be like, oh yeah, this is, we know this already.
You're wrong. You're wrong. Sorry for interrupting.
Well, I'm not wrong. Okay, I'm telling you, I'm not wrong.
Let's go to a different topic.
Yeah,
you're wrong. Let's go to a different topic.
Yeah,
but you're wrong. Let me just say, defend my position there. That you're wrong there, thinking that I don't understand, or I'm not understanding. I do understand, but I'm not accepting. I'm not accepting the explanation that's been given. We started off with gyroscopes, and that didn't take it into stars, and I said we shouldn't go there.
We're going to move on. We're going to move on to another topic real quick. If you understand these topics, and I've already explained the velocity is the first derivative, acceleration is the second derivative. What's the third derivative of position then, if you understand this topic?
We were talking about
what all flat earthers are.
Inertia there. Right, so I don't... Right, go, what's the third one then? Go, no.
Jerk.
What's it called?
Jerk.
A jerk.
He was making a joke.
Yes. That's what it's called. It's called jerk.
All right. Let's go to something different. What are your views on
I'm tired, baby.
Space existing?
Well, yeah, of course it does.
Good. All right, fight the flat Earth.
Okay, so if space exists, do you accept the observations that everything else in space that we can see is spherical?
Well, that's what I've got a problem with. That's with the.
I mean, I bought my daughter a telescope for Christmas, and there's only been a couple of clear nights in Scotland. I'm sure you're aware, but there's been a couple of nights where we've been clearly able to see spherical things in the sky, and everything that is observed is a sphere. All the other planets in our solar system is a sphere. The sun is a sphere. The moon is a sphere. So why isn't the Earth a sphere? What caused everything else to be a sphere, but didn't do it to the Earth?
No, that's a weak argument, isn't it?
Well, not really.
It's a good question.
I'd like. It's a question. Why is all that round, but we're sorry? Why is everything else spherical? Everything in the universe that we observe, but we're not. Why are we different?
Yeah, but why would it? Why could you look up there and say, "Oh, they're round, so we must be round"?
Because there's nothing else that's ever been observed that's flat.
Yeah, you'd think the same properties would affect our planet.
There's a reason why everything else is spherical, and I know you're going to hate this, but the reason is gravity. Once there's a certain mass of something, the gravitational force causes it to become a sphere. And that's why everything else that we observe is a sphere. And then we can look at everything that's happening throughout the universe, and it follows the mathematical law of gravity. We can use the calculations and the physics that we understand to explain and predict everything that's going on. And gravity is the thing that helps explain that. And if gravity is a thing, and Earth is a thing, there is absolutely no way it could be that big and not be a sphere. Gravity would have made it into a sphere.
Well, they were predicting things 10,000, 20,000 years ago, before science or whatever you call it, astronomers got a hold of it. So they're not really predicting new events in the sky or anything like that. They've been doing it for thousands of years.
They certainly couldn't predict things with the accuracy that we do.
Well, they certainly
and there's
could.
A lot of things that they couldn't predict that we can predict.
They could predict weather, hurricanes, and everything. So using looking up into space and stuff like that is nonsensical to me.
I'd like to hear the answer to that question, though, because I think it is a valid question. Why everything else in the universe would be round, but we would be different? Why would the principles of physics out there be different for us?
Well, all we can see is like apparently 7 planets. So they're the only things, and the sun and the moon. They're the only things that look round. The rest is just lights.
I would have to disagree with that. There's over 100 moons in the solar system that we can observe. There is a whole bunch of like protoplanets throughout the Kepler belt and everything. We can observe, planets orbiting other stars that we can tell by looking at the dimming of light on the star as it passes what shape they are. There's way more than 7 things that we can see that are spherical.
All the stars. I mean, when you look up in the sky, it's full of stars. What do you think? What do you think those are?
How do you know? How do you know the shadows are? How do you know they're not like you get black spots on the sun? How do they not know it's that?
Huh?
What? And they're reading
that. Very different.
The sun's over here. Like,
well, black
setting.
There must be obviously there's a different signal that comes off black spots off the sun, right? So why are you using it in front of a star?
Wait. Are you talking about sunspots?
Right? Sunspots. Does it matter? You knew what I meant.
Are?
I knew
but I'm trying to figure out if you know what you mean.
Well, if you go, well, which explanation? I was told they were because they were. This is going back a few years because they were. They weren't as hot as the outside. The brightness of the surrounding area hid the colour of it. That's got to be
it's
about
just a
20 years
contrast
ago.
difference. If you couldn't see the rest of the
Oh, it's
sun,
still
the sunspots would be very, very bright. It's just that they're less than their surroundings, so there's a contrast issue because of magnetic flux densities. But
I'm talking about like
but
our
they're still
backgrounds.
pretty.
You can look.
Sunspots
You can
are
go to
still
the
very, very
country.
bright.
You can look up and see skies that look like that. I mean, what is your opinion that you think those are?
Well, well, I believe that their lights are on a different spectrum, on a different end of the light spectrum that we can't see, and
But we can see
they
them.
actually. Yep, but I believe that the atmosphere actually, the reaction of the light that they're producing reacts on the atmosphere, and it manifests as them little twinkling things. But they're obviously something producing a light source, but I believe that the atmosphere illuminates them.
I mean, that's quite a big claim. Do you have any proof of that?
Well, okay, I'll tell you. Right, well, actually, there's some fascinating photographs from the moon. You know, sorry, flat earthers, but I do believe in the moon. That they actually took photographs, I think it was in '72, infrared of the stars. They had to take it in infrared, and it was quite a fascinating.
You do realize that
pictures
we've actually seen the disk of Betelgeuse and Antares. I mean, we've actually have actual photographs of these stars. They are round, right?
Yeah,
and
well,
they do this.
And then
stars
with,
are
with
one.
the stars, and like I was saying about with you can look at the dimming of the stars, and you can tell by that what the planets are that are orbiting around it, and then we can predict what the orbit of the planets going around those stars are, and then we can use parallax observations to figure out how far away from their own star they are. And everything else is a sphere. Everything that we have seen ever is a sphere. If it's big enough, its mass makes it a sphere. And I just don't understand why we wouldn't be a sphere if everything else is. What made them a sphere and not us?
That's not a very, just because you can't get your head around it doesn't mean that it's true. And I mean, that's, what does you call it? What is it? Argument of incredulity. Or what do you call it, Steve?
Correctness.
Incredulous.
I'd have to disagree because I can explain the physics that explain why everything is a sphere.
Yeah.
So I'm not arguing from incredulity. I'm saying that the physics of the observable universe says that everything should be a sphere. The physics that we can use to calculate and predict everything that happens says that everything should be a sphere if its mass is big enough. So why are those physics not affecting us? There has to be something else.
They physics were taking on the assumption that they see the moon, it's a sphere. So we must be a sphere.
There's no assumption.
No, it has to do with the fact it's at ground state. It's at the lowest potential energy for that system. Things like to be at equilibrium, and spherical is the lowest state of potential energy in a field, like a gravitational field, because of its own mass. So it's going to be at least spheroid in some way. Most objects generally are, because that's the lowest state of potential.
I mean,
right?
all the when they show water in zero G, it always seems to form. It always forms a sphere.
Well, that's
like
because
Steve said, it's the lowest state of equilibrium.
That's because of the bond. That's because it bonds together. The bonds,
the surface tension wouldn't.
Together.
Yeah, but the surface tension would be dependent on the surface area, and no matter how big it is, it's still going to form a sphere.
No, it literally holds itself together. Water.
Because of gravity?
It holds itself, the bonds.
Yeah, but why is it holding itself?
No, it's because the water bond is because of the bonds. The
there's
bonds
van der Waals bonds.
Right, and they're stronger than the will for it to fly apart.
And that's will for it to fly apart.
Well, you know what I mean. To want to go.
I actually didn't know about that one.
To do. Right, it does. It holds itself together. Water holds itself together. So.
Well, it's called van der Waals forces. They're intermolecular bonding between the molecules.
Yeah, and it doesn't create pressure on the outside. It's because of that. It's actually pulls in. It holds itself together, so it doesn't create a pressure on the outside of it. So it's not pressurized on the outside.
Okay. Anything else?
Still don't feel like I've had any of my questions answered, but
like
I mean, we could move on
questions?
to other.
No, don't
There's
do
the
that.
explanation of why the physics are different for us as to everything else.
When did you ask?
Why
that?
aren't we a sphere?
Oh, right, that.
Well, that's been my whole point.
Do we have to be? Do we have
yes,
to be?
Because of our mass.
No, the presumed mass.
No, the
And you
mass has
just
been
looked
measured
up there,
accurately.
Look, listen. Oh God. Right. Anyway, right. But the point is, when I don't want to go into that guy, man. But on about just because the moon is round and the sun is round and Saturn and all their planets are not perfect. Their little moons are not perfectly round. They're lumps of rock. Why didn't they? Oh, they've came off another planet or something. They've been battered off another planet, like the moon allegedly came off of us, a collision, and formed itself into a round ball. Yeah, of course.
The mass is
Well,
sufficient
that's
over
what,
enough time that it becomes clear.
When that gets explained to me, that doesn't cut any ice with me. That's not good enough for me, and that's why I don't buy it.
Isn't that just the argument for incredulity on your part?
No, it's not. No, it's not incredulity.
Can I ask a question?
I think about it.
This is a little bit more just baseline, but why would or let me ask? It's two questions actually. Number one, why do you think that there is this cover up to not reveal what the true shape of the Earth is? That's number one. And number two, with all the people that are involved in the space agencies around the world, how does something like that stay between them all for so long?
Well, I just think that when I see satellites go up there or what's happening up there, I just see like military. That's who's up there. It's the military. And then you'll go into national security, and you know how they hide things under national security. How many astronauts are there? There's not really. I don't think it's not. It wouldn't be a hard thing to cover up, because most of the people that work it on the ground level, you know, they're not up there in space or whatever. They're sat in front of computer screens and that. But
they're still they're still doing like work.
It's all about,
you know.
Well, I think that they're just, for some reason, they're deceiving either the size of it, right, the size of the place, or what space actually is, what's actually happening up there. And it's to do with military. It's certainly to do with the military, because they piggyback every single satellite. So I would say security, national security and stuff like that.
Okay,
that's
but
the best. And these people sign one second, and the reason that maybe the astronauts don't say anything is because they'll sign an Official Secrets Act, and that means a lot to these people, because if they're military, they'll go behind it, and they've got their job, their wife, and their family. So
let's say I grant you that for the past, maybe 200 years, but we're going back hundreds of years when a thing of like the military that we're talking about these days, that's trying to be Big Brother and look over everything, that concept didn't exist. So what would be the motive back then to change it from a flat Earth to a round Earth?
Oh, I never said it was. I don't even know. I think you've got to go back tens of thousands of years, I think, actually, to find our culture that actually even believed in the flat Earth. But I certainly know why they started promoting why the church certainly started promoting the ball, is because they were getting worried that now science was taking over. They were beginning to discover stuff, and they realised, well, you know what I mean, like any organisation that wants to survive, it just embraced it and ran with it and took it over, basically co-opted it and took it over. And that's why they promoted it. They didn't shut it down or anything like that. They encouraged it. Whereas the story
it still doesn't
says that they shut it down.
Change that physics is right. Whether it was co-opted by the church or whatever, it still doesn't change the fact that physics is right. The physics that we have that explains the universe, and the mathematical formulas and mathematical laws are all right, and they're all dependent upon everything that we understand. And if everything works like that, and all the laws and the formulas are right, which we've proved they are because they work, then the Earth is round. And
right,
unless for some reason somehow they have changed the nature of physics, that you can't explain there being a flat Earth.
Well, they've changed the definition of gravity.
No, they haven't.
Well, they have. It's an upward acceleration. The same. They describe it the same as the Flat Earth Society, but it's an upward motion. It's an upward acceleration.
No, it's a downward force. The Flat Earth Society subscribe to a theory of universal acceleration that says that the whole Earth is moving up at 9.8 meters per second squared, which would have its own problems with relativity anyway. But within a year would be traveling within 354 days.
It'd be faster than light.
Light.
Yeah.
Right. Let me finish in. So,
what does the word orthogonal mean to you?
Oh, Kyle, no.
Orthogonal or a tangent. Take your pick. Pick one. 50.
Right, if I've got a triangle and there's like one.
The Earth is not Blake.
Allie, come on. You've been doing this a long time, and you still don't know what tangential or orthogonal means? I mean, Allie, come on. Dude,
what do you mean orthogonal?
Take a best shot.
But these
What does orthogonal
these are
mean?
words. Well, a tangent isn't that the intersection of a line or something like that.
Tangent's what Steve goes on every night.
An angle
Yeah, exactly.
intersects another line or something like that.
He's like so close. You want to? I mean, it's like he's like almost there, but not quite. It's,
But I don't care.
know,
It's immaterial. The point it's
But
immaterial.
it's immaterial.
Geometry, fuck it, right?
This is one thing that confuses me.
Listen, guys. Wait a minute. Let me think. Let me just say something. Let me think. God, that's hard. But let me just say something. I usually say things about things. But it's like I just don't agree with I don't accept the explanations that I'm getting. It sounds that they begin to what I just said there. It's a fact that science, like Einstein's whatever his equations, whatever they pulled out of, they changed into it. It's an upward acceleration, not a downward acceleration.
No, it's really not.
I don't know what the hell you're talking about.
Well, I'm sorry,
dude.
it is. Yeah, I know. And, right, one more. But it is a fact. It is a fact.
It's really, really not.
It's a fact.
I'm sorry,
No,
but you're
All right,
completely wrong there.
I'll put it, and do you know what I do? I won't even put out a bet. I won't even put out a bet there because I only bet when I'm going to win. But I wouldn't want to take money off you. But it's a fact. But anyway,
Okay.
I'll come back to that at some point.
I have an equilateral triangle here. What are the measurements of the interior angles?
So the sides are 1, 1, and 1.
Right.
What are the measures
60,
of the angles?
60, and 60.
Boom.
Yeah.
Well done.
Got it.
You are smarter
okay.
than
Oh,
Anthony
see?
Riley.
Yeah, if you haven't seen Anthony Riley do this,
Well,
you have to watch
actually,
it. You have to watch it.
I was going to get it out
Oh,
earlier,
I-
but my
I-
episode 6 of Flirts Are Idiots, Sleeping Warrior, will be out about 20 minutes after this show finishes. So, just saying.
Well, he just says some really stupid things.
Oh, yeah, he does.
You think?
He does cherry pick. He does cherry pick stuff. And
I
stuff
like
that.
Ranty because Ranty actually proves the flat Earth model is bullshit. He actually gives evidence for
He's not
Earth.
flat Earth.
There is an interesting question
No,
from
that's just how
the
you
live chat.
see it.
Weird.
That's how
Alley.
you see it. You know.
What are
No.
your views on the ice wall? Does it exist or not?
Yeah, that's a kind of hard. That's I believe I'll answer it straight. The ice wall. Well, if I go, as I say, I believe what I see is the flat Earth. So the water has to be contained. It has to be contained in some way, right? If it is as I believe it's flat, it has to be
contained.
That's just physics for me, anyway. Like a cup in
Why
the
does it
water,
have
I
to be
know people
contained?
say it changes.
Like the
Otherwise it
natural
would just
physics, this is
flow.
something that a lot of flat earthers say, that water
Otherwise
has to be level and
Well,
contained,
actually,
but
do you know what it could
it's a
do?
misconception, right? If I could just explain this, it's a total misconception.
No, let
the,
me just
the physics
let
of
me finish my
water
point.
is that it will conform
One at a
to
time.
the forces acting upon it.
Allie, hang on.
That's the physics of water, is that it will conform to forces acting upon it. And if those forces happen to be the walls of a container, that's the force acting upon it. And I know you're going to hate the answer, but do you know what the force is acting on Earth that
Drop
keeps
it.
the water conformed?
Drop
Gravity.
Weight, isn't it? Weight. But anyway,
so-
about the water,
Makes no
right?
force.
Right.
Yeah.
Oh, wait a minute.
Go
Let
ahead.
me just
Go ahead,
say
Ali.
about the water. Right. About the water, right? So I said it need to be contained, but if it had a big enough area to spread over, right, I think possibly even by its mass, if it was 100 or 500 mile long, I think it could possibly, once it's want to spread out, I think it would. If it wasn't wind blown, I think it could actually sit, like the top of a cup. I still think it could possibly sit like that because of the, it stopped trying to push out, so it's settled in its. Well, it's just settled like that. So that's the viscous. You know how you see if you look at a cup or whatever it's called, you can see the water. You can actually see the water curving on the top of the cup. So.
Putting a countdown on real quick. You can keep talking. I'm just putting a little countdown.
Ali, work with me here real quick. Work with me real quick.
Yeah,
do you agree that if you have two bodies of mass...
Don't confuse me with big words. Yeah, but don't confuse
I'm going to use monosyllabic
words.
I'm going to keep this... I'm going to try to keep this very, very simple.
Very
I have two balls. Okay, can you imagine me having
Yes,
two balls? Picture
most
me
people do.
having two balls. Okay,
It's
so I have
a
two
bit of a
balls.
stretch, but yeah.
You're going to bring it down to grade school level, and even in the gutter. So I have two balls. Would you agree that there is some kind of attraction between my balls?
Yeah, if
Not
they
between
get
you and my
close-
balls, but between the balls themselves.
Yeah, yes. If they get close enough, yes.
Okay,
I agree
okay.
there.
So my
Oh my god!
I'm trying to get through this, man. So if my balls are almost touching each other, they're going to have
Stop
some
it!
force
Just
between
stop!
them, right?
Just fucking stop, man.
Okay, so imagine having a single ball, okay,
No.
and I have water
Why?
around it, like the 3D sphere. Okay, so I got this water around it. It's all going to be attracted to that sphere. So if the sphere has a lot of mass, has a lot of gravity, all that water is going to be attracted toward it. It's going to be around the ball. You got to have it around the ball, man. Balls are important.
That was. If you thought that was going to convince me, and you'd be the ball earther, that was poor. That was. I'm sorry, Steve.
So the ball
You're
I
not
think he's
being-
trying to make a
another
joke about the
reason that-
Cavendish experiment and his
But that was-
genitals.
Just don't
that
let the
was
balls
bad.
touch. If you don't,
Well,
if balls
I
aren't
don't-
touching, you're okay.
Well,
Yeah, but no,
Um,
I don't. Sorry, that's not convinced me. I'm still going away. a
People are
flat
just
earther,
tuning
I'm
in
afraid.
right now. Are really going, "What the fuck is Steve talking
all right.
about?"
let's
Okay.
let's go to the final thoughts, I guess.
Yeah, final thoughts.
Fight the
My
Flat
balls
Earth.
are too much for you to
Start
think
us out.
about.
I think you're almost getting stuff, and for some reason, at some point, it just goes off on a tangent. And I just, the guys are right and the chat are right that it seems to have just been going around in a circle because we're almost agree up to a point, and then you just stop agreeing with the logic and the sense and the physics of everything else. And I think that no matter how much I explain these things to you, you're still just going to say no because I don't accept it. And that doesn't make sense to me because everything else works. The physics that we use and the maths that we use and the mathematical laws and equations, they all work to predict and calculate everything that we know. But then for some reason, according to you, everything just stops working when it's around the flat Earth. And that just doesn't make any sense in any kind of way as far as I'm concerned. So I think I've shown here that you have a lack of knowledge about the actual physics of the universe. And maybe if you spent some time studying the actual physics rather than what you think is physics, you might come to the understanding that the Earth isn't a fucking magic space pizza. It's an oblate spheroid with a circumference of 25,000 miles that's been demonstrably proved millions of times. Up would have to be bigger. Is way, way, way bigger. There is. I've at last count when I was looking, there's 24 companies that will actually take you on an excursion to the South Pole, and you can stay there overnight. There's people recently that have gone across it, and it wasn't an ice wall. It was a round continent because the Earth's round. I'm done.
That would be a good piece of our show, Steve. If we sent Fight the Flat Earth and Allie to the South Pole to be our ends of the earth correspondent, our senior ends of the earth correspondents. What do you think?
Actually, we had Landon Kurt Knoll call me from Iridium Satellite from the South Pole. He actually called me from there. There actually is, I found out, a flat Earth cruise that a bunch of flat earthers are getting together to cruise around there, and they're using navigation based upon a round Earth to get there.
God help them.
Oh, you can't write that. By the way, Allie, how do you explain this?
True.
This behind Steve and I, this is actual footage from NASA. So how do you explain this if Earth isn't?
I mean, it looks so fake. It has to be real,
time.
right?
Well,
Up
it's
there,
real.
yeah.
It's real, man. It's real. I can't dispute that.
All right.
What I'm looking
Positive,
at
baby.
is real.
All right, Allie, give us your final thoughts.
Yeah. All right, my final
You can
thoughts
spare
is
any.
I got kind of what I expected. Well, actually, yeah, I got treated very well, and I thank for,
We love you,
thank the
Allie. We just
guys
give you
for letting
we
me
just
on.
give you shit because we like you.
Yeah, but it doesn't affect me, kind of thing. I've just I still hold true to my opinion. Fight the flat Earth. You've not convinced me in any way at all whatsoever. And I could say exactly what you said there. I could say the same to you. You're not willing to actually even conceptualize either you want to be part of a gang or you want to be popular or you want to get loads of subs and stuff like that. It's whatever you're up to, but and that's what's holding you back from even looking into it. That's it. You won't even look into it. I'm like, what shall I say? Well, I'm honest enough with myself to say, and when I get evidence, it'll have to be good evidence, and when it will, this will be the first place I'll come straight out and admit. I always admit when I'm wrong, and if I find evidence, I'll bring it forth. So,
You
thank
don't
you
think
very
that
much for having me on.
that giants blew the moon from glass, right?
No, I'm not one of them ones.
Okay, just checking.
But they're interesting
And you,
people.
you,
They're-
don't- you don't
you
think
know,
that the Earth was made by dragons distributing the continents about either,
Oh
right?
yes. Oh, in fact, let's see if I can do this before we close out. I think this is worth a look. Let's see.
So
Bear with
when
me.
we were doing the debate with Edgewise, I usually write notes during debates, and that was the entire notes that I got.
I got to tell you, I don't think anything was coherent from him. I didn't even know where he was going with half that. It was just nothing I could even begin to even try to discuss with him. It was just bizarre.
Well, I'm gonna pull up. I'm gonna pull up his latest video, and I want you to see what he has found because this is truly groundbreaking, y'all. I mean,
Is this the one directed at us, or is it a new one?
yeah, it's the one directed to us.
God,
The title of the video is NonSequitur, Fight the Flat Earth. Time to man up.
I've
let's
always
see.
wanted to
Go
man
watch
up.
that.
Let's see what he's got for us.
One of these days.
Okay. Tell me if you guys are going to be able to hear this too.
All right, but then screen the end card.
Yeah, I'm there.
Okay. All right, let's do
Steve,
this.
talk to people about something for 2 seconds while I pull this up.
What the hell you want me to talk about, man? We just
I
got
don't
done trying to explain to Allie some basic physics concepts. I mean, like I said,
Okay,
Allie,
ready.
we like you, man. You've been a great sport about this, but God,
I mean,
you're nice.
to be
but
fair
you're
to
just
both
so
me and
wrong.
Ali, it is 5 o'clock in the morning here.
Here we go.
Excuses. No kidding.
All right.
Do it.
Let's see what he
Black
has to
Platters,
say.
you're awesome, man.
I can't hear anything.
Okay, here we go. Listen,
What's
bird
going
feathers.
on here?
Are you ready, Steve?
I'm ready. Do it. Do it, man. No.
Yes,
Oh my
Africa,
God.
yes.
That is not an astronaut. It's a freaking.
Look at this big bird.
Priest that was
Look.
going descending into
Look.
on the altar.
Look.
No,
Dragon head.
no, I
Dragon
can't.
skull.
Stop it.
Imprint
No.
off. Cross-sected out.
Oh, they don't have any audio from the video, by the way. But can they hear us?
Yeah, they
'Cause
do.
I'm dying here.
There's the Pakal
I can hear the audio.
Yeah, they can hear it.
So he's saying that ancient
That's the dragon
astronaut
head.
was actually
Look.
that
Oh.
big.
Oh,
There it is, guys. The dragon fossil.
this dude needs to lay off his psychedelics, man.
Okay, I want to point out one thing before we close out of this, though. Look at these right here. He's saying are bird. It's an eagle. Look, see the beak?
No.
It's a giant
Well, you
fossilized
see.
eagle, and there's its
Let the
feathers.
audience decide. I could tell you what this is.
Rock formation?
But you'll just
Pareidolia?
Oh man.
And why
I
does he
think
think
that's
this
that's
proves
that's the fattest
anything that
flat
we
Earth.
didn't?
Ah, come on, that's worse.
Why?
Edgewise, I don't know how you want exactly us to man up, but here, if you know,
He wants
you know
to
where
come
to
on
find
and
us.
debate me again.
Oh, well, he knows where to find us.
He's like I said, he left so many messages, comments that it like filled my spam folder was ridiculous, and he's desperate to come back on here and debate me again.
Over what?
I mean,
the
if you
giant
want the
eagle.
biggest clusterfuck ever,
Yeah, what is that a debate? It's not even a worthy discussion. He blew his load the first time and said, "Here, here's all this freaking shit that I think I see." Well, you're wrong. Okay, move on. What's there to talk about?
You don't.
he's telling us to man up, but who's the
Right.
one that hung up on that call and then ran away?
Look. You can't. You
True.
cannot follow or beat African Sahara fossilized dragon. Okay.
That's-
When you do that, that's your move. It's it after that. You
Yeah, he
can't
blew
top
his
that.
whole load. Yeah, he got nothing left, man.
But if he wants to try, come on. You know, Flatter Day is the
Whatever.
day. So just send me
And
a message.
Maybe we should have Allie and him go at it. Flat Earther against Dragon Seer or
No,
something.
we need Khaleesi and Tywin Lannister to go against him.
Ali, what would you say to him? Like seriously, from
What
your
about
point of
the
view, what would you
dragons?
say to him? Well, yeah, he literally thinks that all the continents and that are like petrified dragons. One of them's eating a giant fish. Like these things have to be thousands of miles big, and that's what caused the continents and stuff. What would you say to him?
Well, I would say that I wouldn't go along with his theory and point out things why I don't believe it. So
Well,
Well,
you turned it around.
Okay.
I can't
After all,
can't
Ali,
really-
on that one.
you turned it around.
What can I say? I believe. Look, what could I say to him? I believe in the flat Earth.
You
know
could
what I mean?
say, "Fuck off." That's absolutely bullshit. There are no
we do
dragons.
it better. but I tell you what,
Let him
Allie,
go
you know
at it.
what?
Let people. Sorry.
Allie, next week, dude, we're gonna have some shots together. You and I. You were nice enough to donate, and I'm gonna get some good, decent whiskey or something. And you and I, we're just gonna drink and not talk about flat Earth, but we're just gonna talk about all kinds of different fuckery. Sound good?
Well, I want to have a discussion with you on because I'll tell you why. Because I was pissed off with you because you were getting the flat earthers. You would talk so bad about them, and I kind of take it a wee bit. It hurts a wee bit, right? That's why it took so long to get it. But then that bottle of whiskey that I promised you about 4 months ago, because I just like fuck him. But you were on, I think about a couple of weeks ago or something like that, and you were on about objective morality.
Mm-hmm.
You were having a discussion, and you were getting pelters, but you were sticking up for your opinion. We share the same opinion, that I'd like to talk about that actually, and a bit of philosophy as well. Because I
Make
can
sure,
learn, I'm always open to learn good conversations.
I'm down for
make
that.
sure, Ali, that you
Drunk
have
philosophy's fun.
your definition of atheist and agnostic written down, so that you can give it to
Come
him when
prepared.
he's ready. That's a prerequisite. He has to know that. So
And objective morality.
Yeah, but I know what Steve is. I've known Steve for a while. He's explained it so many times what
Oh, yeah.
he is
We go
as
way
an
back, man.
agnostic, so I get it. Yeah, I get it. So,
For, he,
but,
you
yeah,
know
I'll
what?
get a good one,
He's a
Steve.
flat earth. Here we
Yeah,
go,
I'm-
people. A flat earther understands it. A flat freaking earther, okay? Not hard. Thank you.
There's another backhand
Allie.
comment for you, Allie. Tell him to fuck
Yeah, I
off.
know. I've been taking them all night.
All right, guys.
Even a fly.
Thank you both
I
for
love your shirt though. Great, you look great, Allie. You look great.
thank you both for coming
Oh,
on
nice one, too.
and having a civil
You-
conversation. I almost forgot what those were. Those were like here on Saturdays.
Yeah,
The past ones
This has been one of the most pleasant experiences I've had. on
He's a
the
nice
NonSequitur
guy,
Show.
dude. You
yeah.
can't say that he's not.
Well,
Ali's a nice dude.
He's not.
To be
He is
fair-
a nice guy.
To be fair, we have put
There's a lot of
Fight the
flat earthers
Flat
that are
Earth
actually quite vile.
with the Dragon
well.
Lord, with Flat
Ugh.
Earth Jesus, Mind of God. Who else have you battled?
Scotty Storm,
Scotty Storm. Yeah. So
Edgewise.
yeah, Edgewise. So next week, guys. I don't know if you heard me announce this in the last show, but we did an episode about paleontology with Dr. Don Prothero, who is a world-renowned geologist, paleontologist. The guy's resume is unbelievable. Written, I think, over 30 books. But he recently wrote a book about flat Earth. And so following his appearance on here, we got brave and we asked him if he would be willing to come and have a discussion with a flat earther. And he said he would love that. So Dr. Don will be here next. I always want to go say Friday, but it's Saturday. Flatter Day. Next Saturday, Dr. Don will be here. And you do not want to miss that. Do they, Steve?
Nope. This is gonna be awesome.
I actually watched a few of his videos. I watched a few of his lectures when you had him on a couple of weeks ago. I
He's
actually went
phenomenal.
on YouTube. He's got a few. He was an interesting dude, man. Very
Yeah.
interesting dude. Giving his his lectures, they were quite
Also-
interesting.
Also, I don't know if you guys know this, but Dr. Grady McGurdy, who is a young Earth creationist, very big young Earth creationist, and got some attitude. He'll be here Friday, so look forward to that. And then we've got Trevor Valley coming on Wednesday. So it's the week of the Dino Dudes.
Mm-hmm.
I like it. All right. Anybody got anything clever they want to end on? I'm kind of.
No, I just
Yeah,
want to thank
exactly.
Ali for actually having a nice conversation again. So yeah, Ali, I wouldn't mind having another conversation with you at some point. I actually enjoyed that.
Excellent.
Yeah.
And don't
Yeah,
forget
it was-
tonight
it was-
we
it
might
was-
be.
yeah.
Oh, good.
And again,
Oh,
in
good.
20
You had a good
minutes
time?
after this show finishes, I'll be premiering my new episode of Thrifts Are Idiots.
And by the
You
way,
probably
thank
don't
you
watch
guys
that.
for 22,000 subscribers. We just hit 22 about 15 minutes ago. Thank you very much. And in return for that, Steve and I have a surprise for you all. Steve?
I'm gonna show my nipple.
No,
Oh, yeah.
tonight.
Oh, no,
tonight.
no.
Tonight.
Oh, tonight at 1:00 in the morning, my time, Pacific, 4:00 Eastern time. We're going to be having a late night stream where we have two people that have a Ouija board and going to be calling up spirits and summoning them live on camera. I've seen their setup; it's pretty nice actually. So that's going to be like 4 hours from now. So take some naps, and then tune in.
And all you UK people, you have no excuse now. No excuse. What time is it in the UK?
9:00.
It's
their
5:05.
That'll be 9
It'll be
o'clock.
9:00 for them. Yeah.
Good deal. Well, I'm going
I'm
to end
6:05.
I just watched a Vsauce video before I came and did our power stream. So I'm going to end on the old Vsauce sign off. And as always, thanks for watching.
End card. End card.
God, that's my job.
God, you did one job.
I had that so perfectly too.
Fucking amateurs, man. How long you
Live
guys
chat
been
didn't
doing
I've
tonight.
been doing this for a while.
And as always, thanks for watching. We're back.
I was watching the live. That was the best ending we've ever had, I think.
Yeah, we're back.
Great.
But I forgot something. You guys can leave if you need to. I know it's late for you guys. So Fight the Flat Earth, Allie, y'all go ahead and close out. We got to do super chats.
Oh.
Oh, yeah, okay. Good.
Right, see you guys later. I'm gonna go
All right.
set up my premiere. Bye.
Thank you. Sorry about that, guys. I almost forgot about
Bye,
you.
guys.
But
See you later.
I would
Speak to you
never
soon.
forget about you.
Yeah, we get those out of the way, people.
Okay. That was so funny. I love how we're
Such
just.
a great ending, and we're already back. Oh my
It's okay.
goodness.
That's how we roll. I just looked at the you know how you have to go through the comments first. The first comment that I'm reading, it's not a super chat, just like regular comments. I am gay and I have zero interest in anal sex. I am absolutely not interested in having multiple partners. I don't do drugs. I don't even drink. Why should I put up with this Christian bigot? Because I have romantic feelings for a guy. Well, we just got up close and personal. Okay.
I know. I learned more about the anus than I ever wanted to by listening to you and Jimmy tonight.
Well, that's Mike Winger for you. Come on. Here we go. All right. Let's do this. Starting with Biblical History Skeptics. Sound lag for Kyle and no sound for Steve so far. Well, that's not a very pleasant one to start off with. Hope it got better. Brian Peck says, lesbian breast cancer risk is from not having kids. Having children and then breastfeeding them has a protective effect. Weird, but medically true. Brian Peck also says, I clarify with he thinks lesbians don't have kids. Okay. Biblical History Skeptics again. I'm here, I'm queer, and Haggard's Law will be a thing. What is Haggard's Law, Steve?
No idea in the world.
Is that like
Never
Merle
heard of it.
Haggard's Law?
Dude, I only comment on shit that I know about.
can't
That I
be
don't
good.
have to sit there and Google. I have no idea. So.
Kiwi H says, if the
Haggard's
Bible was
Law.
like
What is it?
supernatural TV show, do you think it would be a better book? No. It'd still suck.
Oh, by the way, Haggard's Law is an adage for Pastor Ted Haggard. Despite him not being gay or in any way, shape, or form, you remember he's strongly opposed to homosexuality. So I guess Haggard's Law is if you're against homosexuality, 9 times out of 10 you're going to be gay yourself.
He didn't turn out to be gay though. Oh, that's Jimmy Swaggart. Never mind.
Ted Haggard?
Yeah.
Yeah, Ted Haggard had a
I was
few
thinking about
run-ins.
Jimmy Swaggart.
Yeah.
You know, they're so
No, he
they
had a
get
hooker.
caught up in so many scandals. It's hard to keep up.
Yeah, he actually got busted with a hooker like 2 miles from my house where I used to live.
FL Camera says, just found you guys and I'm enjoying the show. Subbed. Thank you. And we're
Yay.
sorry.
We enjoy you too. They had to listen to my ball- about my-
SSDDG
you're talking about
Blue
my
Falcon
balls
says, hashtag real planets have curves. Hashtag dwarf
Yes, they do.
planets too. Hashtag long
Sexy
live Pluto.
planets. Sexy planets.
FL Camera again says, thank you for this show. I'm so into filmmaking. So he left one
wanna raise your
saying that he
volume a
found
little
our
bit?
channel and subbed on the Ouija board one, and then came back and watched the CGI one. So thank you for that.
Nice. You got
Cajun
to raise your
Drifter
volume a little
did
bit.
not
Kyle.
leave
They
a
can't
message,
hear you.
but thank you for your super chat. Fact-based living says the vein covers the hole on the rotor case, which causes it to precess until the hole is
Precess.
no longer covered. It's not rigid. Okay. Cajun Drifter, are we discussing inertial navigation systems? If so, inertial nav has been laser-based since the 80s. Fact-based living, every time you turn an aircraft, the gyro process, this is why we use gravity to reset them. It's the only force that can assist us in that task. 0132 Beer Money, also weight is a force near Earth's surface. Weight equals G times M. Weight equals gravity. Actually, I gave you
I disagree.
the formula for dropity. It's buoyancy times weight plus height divided by density.
Or actual physics, weight is the force of gravity acting upon an object.
And then, last but not least, oh, damn. From Sean Hawkins, it's it's like watching Ringo Starr with brain damage on acid. God.
Ooh.
Okay. Cold-blooded. All right.
What a way to go out. Ouch.
Here we go. Now we're good to go. Sorry about that false ending, guys, but let's do it again. Thank you once again for 22K. We'll see you back here tomorrow, where Katie and I will be back on Sundays for the Smoking Nun, and then we'll be back at it on Monday with Non Sequitur. And as always, thanks for watching.